Okay, good afternoon, everyone. Today we continue our discussion, but first of all, we want to just run a very small example to talk about cross validation using just one sample example as a SVM. So, having said that, please go to your Moodle. Under week 5, download cross validation with SVM. We talk about the second line in the next class. I think it's better to have like each class, maybe we can focus on some certain part of predictive analytics. So please download, you can download both of them and even practice with both of them. So I also recommend to work on the second one at home, but for today, please download cross-validation with SVM, and I'll give you like 3-4 minutes, and after you download it, please click on it and load it into your NIME. So you have 3-4 minutes to do that. Let me see if I can use this camera for your friends at home. And okay, it's recording. Okay. Okay. The point of what is the point about prediction? If I want to summarize it, we want to use the current data, train a model to do a prediction in future. So basically, we don't have the future data to evaluate the performance of our model in future or on new data, but we can practice performance of our model, either accuracy, ROC, sensitivity, specificity, precision, any model, any performance measure that you can make on our current data. Then if we have a stable results, we can be pretty sure that it could perform well in the future, that we don't have any idea about the dependent variable. So having said that, this is my current data. Something in future will come up. Let's say stock information. And actually, there's a good paper. Somebody predicted the Apple stock price in the next day. So I don't have this data in the future, but I have this kind of data to train my model. So what can I do? I can use a portion of this data for training and a portion for test. So I use this one to train or make an algorithm and predict this one. If the performance is very good, I can assume I might have a better prediction somewhere in future. But you might ask me why I choose this test and this one as a train. So basically you do by random seeds. You just randomly let the system divide in two sections, but still it might not satisfy for you. For this reason, we introduced the k-fold cross-validation. So with k-fold cross-validation, I divide my data into k-folds. This is just an example, 5 folds. The most famous segmentations are either 5 or 10. So I divide my current data into 5 sections. Section 1, 2, 3, 4, and so what I do each time, I use 4 sections for training my model and 1 section for test. Again, this segmentation happened randomly. So let's say first I use section 2, 3, and 4, and 5. 2, 3, 4, 5 for train, and section 1 as test. And I record the performance of my model. Again, what I do the next time, I use section 2 for training and the remaining for the testing my model. And I do for all 5 sections. So what happened, I have 5 train and 5 test evaluation. So what I do, I say, let's put 1. Fold 1, 2, 3, 4, 5. Or let's say test fold. Let's say accuracy of folds. 80%, 82, 60, 79, 81. So I had 5-fold cross-validation and accuracy. On top of accuracy, you could have other models like AUC, sensitivity, specific. So as you see, 4 of them are very close to 80%. 1 of them is just 60. So it seems that I don't have a stable model. There is such a great differences between accuracy of the folds. You are not very confident to use it in future because with some random data, your accuracy is drastically different. So you don't have confidence to use this model in future. Versus if the accuracy was something like this, 79, maybe 81, 82, 80, and 80.5. Very close to 80 is a very stable model. So even in future, you have more confidence to use this model. So this is the concept of cross-validation. So we randomly divide our data in folds, random folds, compare the accuracy or other performance measure, and if we have very small deviation and high performance. For example, if all of the folds are near 60%, is that a good model? We want high accuracy. If all of them are on 90%, that's again a good model, a better model. So we want high performance and stable results. Having said that, if accuracy of your model is not that much great, maybe the features that you chose is not good. Maybe you should include new variables. Also, it's same for high variation. So if it is high variation or low performance measure, it could have something happen. One of them could having not having good variable for prediction. Any questions so far? Okay, so let me just move it a little bit. So a lot of times you don't have that much of samples. You know, in many prediction analytics problems, we work with thousands of examples or observations. So when you have high observation, you train a better model. So one of the things that you might have a low performance is not having enough observations. So what can we do basically? We can increase train set. And so if we have a better train set, more observations, we have better prediction. So in those cases, what we do, each time we just take out one observation as a test and do the prediction with the remaining. We call it one leave out. Let's say I have 40 observations. Each time I use 39 as a train. I use just one as test. You might have a high deviation. In those cases, you have 40 predictions. You just report the median. Not the highest, not the lowest, the median performance that you have. So we call it one leave out. Even sometimes you might have 12 observations. One of the good examples of this problem is survey. So last year we had an analytics competition, and the survey was about 30, 40, something like that. So what they use one leave out prediction approach. Any questions?
And how many iterations do we do with this? Like
40. If you have 40, yeah. You just one leave out. So each time you just put one leave out as your test and use remaining as for train your model. Any other questions? Also from people over Zoom? Okay, let's erase this one. In many cases, also your observation is not too high, they are not too low. Let's say you have 400 observations, still performance of your model is not that much great. So it doesn't make sense to just leave one out and do 400 predictions. What you do sampling, or more specifically, bootstrapping. What happens with replacement? Let's say And there is no general number, but if you want to use in project, please just Google it, how many samples you should have in bootstrapping, and just have a reference. There is no biblical rule for that, but I mean, you can easily find the reference. I think in one old paper I saw it was like square root of n. So let's say square root of 40 is 20. Maybe I do 20 bootstrap sample. Or you just Google it, I can easily find, just let me, if you're using your research or your final project, just say it was your reference for this amount of bootstrap sample. Then instead of just doing one, amount from your 400 observation, let's just you just take some percentage by chance, that's 20%. Again, just find a paper, it might be different in different fields, but let's say 20%, just or 10%. Let's say I pick 10% or 20%, whatever by chance. So it will be my test cell and the remaining train cell. Next time, for the second sample, I do by replacement. What I mean replacement, in second sample, it might have some overlap in the first one or somewhere here. So anyway, again, you do, let's say here 20 samples, you do train, test, and prediction. And at the end, you report the median prediction. Or you use the median model for prediction. And there is modules for all of them. If you want to do Python, you need to do by yourself, but there is, you can just Google find the module for 9 and use it. Today, we work with the cross-validation and one leave out module. So if you need working with bootstrap sampling and interested, just let me know. Maybe the next class I can bring a sample of bootstrapping and just see how it works. In some of your projects that I've talked with you, I guess bootstrapping could be one approach if your prediction is not that much great. If you, let's say you have 10,000 observations, bootstrapping doesn't seem to be the right approach. Cross-validation is more than enough. But let's say if you have 40 observations, if you did a survey, you should do one leave out. If you have like 200 observations, maybe bootstrapping could be a good approach. And again, number of samples or the percentage that you specify for the test set should be referenced from a source. And I look at, again, as a heads up, for your final project, let's say your prediction has 80% accuracy, then you should explain your effort for improving that. Maybe you can say you did this module, you did this and that. Maybe you couldn't improve, you couldn't, that should be fine. Maybe you do bootstrapping, but you cannot improve. Maybe you do one leave out, you cannot improve, that's fine. Just report your effort. So I want to see your thought process. So it's very necessary in your final project that you try to improve performance of your prediction. It might be a very difficult problem, and you do your best, but you couldn't have more than 70% prediction as accuracy. So that, again, that should be fine. But I just want to see what you did. Maybe you include new features. Maybe you do feature selection that I explain later. So at the end, I need to see your effort and see what you did. So we have seen different approaches, I mean, for having better performance, in previous class we talked about outliers. Why it could, what's their cause, what can we do for them? Again, the best approach is imputation, unless you are very confident that it's better to exclude. For example, in one of my research, I look at the patient's weight, and I had a 30 years old patient with 10 pounds weight. Definitely is a typo. I cannot impute. I just said, and I was not sure even the remaining data of that patient is correct, so I exclude that patient. I could just exclude the weight and impute it, but I was not confident about the whole patient data, so I exclude. So you need to have some judgments why you exclude outliers or why exclude anything. But generally speaking, if there are empty cells, the best approach is imputation. Because with imputation, okay, I think I explained previous class. Kennedy said, if I impute new variable in the cell, do I create new information that help my model? Let's say I have a numerical column for the patient's weight. So somebody could be 220 pounds for sure, 180, empty, 170, 160. I'm not sure what could be median. Let's say, I'm just throwing a number. Let's say 155 is median. Or no, 155 is too low. 170. 170. And I might be wrong. And I include 175 there. So do I create, do you think using this information could improve the prediction, or did I create a new information for my model?
I think it's a derivative information based on the information we have. And of course, it has a possibility.
Actually, right and wrong. First of all, yes, we derive new information, but this column doesn't improve our performance, because this information is just derivatives. But why we use that? Let's say I have another columns of cardiac status, or let's say blood type. Let's say A, B plus B, AB, or A. So I exclude these two. If I don't impute, just exclude the rows, I lose these two information. I use AB and B plus. So yeah, it could improve the model by keeping other information. If we don't bring new information into data set or in our model, we just keep the potential information that we could lose. So it's one of the reasons that in your project is, but whenever you see empty cells, the best approach is just imputing. Let's say I just have one AB patient. Do you remember about the bias prediction in the last class?
The video that you showed us.
So if here I exclude AB, I don't have a good model for predicting an issue in the patient with the AB blood type. So excluding the rows might cause some bias in your model. It's one of the reasons that you could have bias. If I look at the data set of the credit card, maybe I could see some female customer, they don't fill out completely. So if I exclude the rows, maybe I lose so many information related to female customers, and I cannot predict the right credit score for them. So again, for whenever you see MT or NAs or whatever, the best approach is imputation. For outlier, you can exclude them, but you should have good reason why you exclude some observations. Or let's say I have, for patient, I have pediatric patient and adult. Maybe there is, maybe you can say you are just treat patient, pediatric, maybe it's better just exclude. So again, for exclusion, you should have good reason. Or maybe you can do a model for pediatrics and another model for adults. Again, exclusion should have a reason, but empty cells, is again, the best approach is imputation. Any questions so far? So these are some factors that I look at in project. Basically, how you deal with the empty information, how you try to improve your prediction, maybe one without bootstrapping or cross-validation, so on and so forth. Does anyone remember another approach for improving prediction of your model? Let's say I use neural network and accuracy of my model is 80%.
I think we can use another one, decision tree.
Yeah, you can, one easy way just to use another model. Very right. So today, we just look at SVM model. We want to do cross-validation. And again, this is one of the approaches that brings confidence for us if you have a good model for prediction. The last thing that I give you a heads up, in the next class, I give you another approach for improving performance of your model that we call it feature selection. I think I taught that if there is a cross correlation between your independent variables, you may not have a good model. So for the cases that you have too many variables, it's better to just focus on the most important variables. So we call it feature selection. So, but no worries, next class we go into it. But just keep in mind, this is another approach. Or in your project, you can just Google it. There's more, you may find some new approaches that you can use for improving your performance of your project. For your final project, I need to see at least you use two different approaches. Could be imputation, could be bootstrapping, feature selection, and the other one that I talk later, but these are, at least I need to see at least two approaches that you use for improving your model performance. Hopefully we have enough time to go examples for all of them, but you can also Google and find there's much more approaches that you can use. Okay, so please load the Stabilia file. So the first one, table reader, if you double click on it, we just get a vehicle data table from 9. In your project, probably you have Excel file. So instead of table reader, maybe you have Excel reader, or you can just here in the search button, let's say, sorry. Excel reader. So if you have an Excel file, instead of table reader, you drag and drop Excel, double click on it, browse to Excel file, and just use it in your project. But again, no worries. It could be even a SVM file, text file, whatever. So you can search either here, find the relevant module, or you can just Google it. For example, let's say I don't know how to bring an Excel file here. I go to Google, how to import, let's say, CSV file into KNIME. You can easily find. So they are talking about read SV file module, and they explain. So either Google, if you have some hints, maybe you can type inside KNIME, or just Google and find the associated module. Let me see. In the newer version, sometimes they let you to drag. So let me drag this one. Oh, didn't work here. Let me do it. Sometimes it doesn't work. Oh, never mind. So, okay, first module, we just import our data. Again, you just copy and paste this address if it's from KNIME website. From your local system, you can just browse. Let me right click and go to read table. Now I can see what I'm bringing into it here. As you see, the first one is row ID, and the other just column names, random names. And the last column, column 18, is just the type of car, van, sub, bus, and I think should be one more.
Hi, Hamid.
Yes?
I don't see your screen.
Oh, you don't? Sorry. So again, right click on table reader, read table, and you can see what you have in the table. So as you see, there's so many random column names, and the last one is just the type of car, either van, sub, Opel, and bus. Okay. The next one is the group module. You don't have to make groups. Basically, when you have too many modules, you can just choose them into one group if you have too many modules, but usually it's not the case for your project. So just double click and we get to inside a group module. You can easily Google how to select and assign modules to a group module, but you don't have to do that. So as you see, the first module is for partitioning, because if we want to do, let's say, 5-fold consolidation, first we need to partition our data into 5 folds. So when I click on it, you can just change the number of folds. So here I just put 5. Class column is the column that you do prediction. And also there is a random seed. This is actually could be an important topic. So what it does, if you identify a random seed, let's say here I change it to 110, then my results should be exactly the same as your results. Or every time that you run on the computer, you get the exact same results. Because here we do partitioning, randomly partition data into 5 sections. So there's a randomness associated. Even if you have the best model, anytime that you partitioning, let's say your accuracy could be between 99 or 91%. There is a small deviation that's totally fine. But if you want to get exactly the same results every time that you run the code, you should assign a random seed, which I did here. Again, if your data is very small, you can do one leave out here. Is that the case for us? Let's say if you have 20, 40 observation, you can do one leave out. But here, we don't do that. So let me go to stratified sampling. Random seed 110. Class columns are my dependent variable that I'm going to predict. As you remember, it was van, sub, opal. So from partitioner, one section goes to learner module, which train my algorithm. I just have to specify class column, which means my dependent variable is column 18, the last column. So just identify this one is the most important, and let the remaining to be default values. These are some internal coefficients for an SVM model. So here we just identify our dependent variable and then click OK. Then after training, one input would be from partitioner, which just my test set. So either fold 1 to fold 5. And one input is what the model that I trained using the remaining folds. So the last one, I just aggregate the prediction result, which is prediction of column 18, and actual column, which is column 18 again. So I have one prediction and one the actual value. So when you want to find the accuracy of your model, it just comes from comparing the actual value with your prediction, and you can see how good is your model. Again, your project, instead of column 18, maybe you have, let's say, a stock value. And instead of column prediction parenthesis column 18, maybe you have prediction parenthesis stock value. So these are the arbitrary names. Then, okay, let me just close this group module. And the last one is a scorer. I just say what is my actual column and what is my predicted value. And that's it. So for running this model, just right click on the last module and press, I think since I already run it, I have it, but for your case, right click and press F7. Since I already run it, it might take 2 to 5 minutes for you, so I just wait a little bit for you guys. So if you're able to run it, just right click and go to accuracy statistics. So what you see on the left side, different row IDs. So my dependent variable column 18 had 4 actual observation of 4 classes of band, sub, bus, and opal. Let's look at their accuracy. So as you see, whenever you have van, you have a real good prediction. You can predict it. Sorry, F means accuracy, sensitivity. Let's look at precision. So whenever there is a van, your precision is almost 80%, versus in sub and bus, in the sub is 61 or 62, for bus 87, and for opal is just 64. It just means you are not very good in predicting. Let me talk again, look at it. So you are not very good at predicting sub and opals, right? The overall accuracy is 7748, which is accuracy of all classes. But it seems in some classes you have low prediction. We learned one of the reasons could be you don't have that much, you have much less observations for opal and sub. Maybe you don't have that much observations, so your prediction is not great for them. So in the next class, we review some approaches. So when we don't have that much observation in some group, there is some resampling algorithm that you can either synthesize or do like boosted sampling to raise number of observations for the classes that you have low frequency. I don't think it could be the real reason, but it could be one reason. So we try what is resampling is one of the approaches that we use for having a better prediction. Also look at let me see. Look at the variances of performance measures. For example, for recall, the lower bound is 472, the upper bound 991. There is high deviation for that. Same for precision. For specificity, it's pretty close, the lower and upper bound. And also for the Cohen's kappa. So it seems it's not that much of a stable model. You have a higher upper and lower bounds. Again, you try to run different approaches. Hopefully, the lower and upper bound gets closer for all of those measures. I think that's enough for today experiment. So in the next classes, I'll bring some more examples on how to try to improve the performance. This is just one single prediction sorry. So it's one basic example of cross validation. And again, we see the problem. In some performance, class performances, our performance was not great. Also, there's a high deviation. So next classes, we learn how to improve the model. So let me close it. Any questions? So if there's no question, we start the new topic. So I just teach a part of it, and hopefully in the next week we finish text analytics. Basically, in text analytics and document classification and topic modeling, all of them are, you can consider as all of them under text analytics. Instead of numerical data, we have textual data. But a question might come in your mind that in modeling, either statistical model or machine learning algorithm, our input should be numerical, but text isn't numerical. So there is some approaches to convert numeric textual data or string data to the numerical equivalent that we use for here. So these are the overall knowledge related to text analytics. As you see, it has overlap with the information retrieval. So having said that, there is some algorithms that they can search the web data, web pages, and take out the information from the web pages. So basically, information gathering or web crawling is a really important topic. Also, information extraction, basically what kind of information you can get from the text that you download, what is the relationship within your text. And the last one is data mining and web mining. So when you get the numerical equivalent of your text data, you can apply machine learning algorithm for prediction. Overall, 85 to 90% of corporate data is in the unstructured format. What I mean unstructured format means your data is not in column and rows. It could be a text document or Word documents. Any information that are not in the table format, we consider as unstructured data. It gets doubled every 18 months, which is a huge coefficient. So there is a significant need to learn some algorithm that you can extract useful information from your textual data. So these are the applications of text mining: law, academic research, finance. For example, there is some how you can look at the quarterly report and extract informations. Some are textual, medicine. Let's say even image processing could be under it, but here we are talking about text analytics. Basically, especially all the time, doctors used to write something about their patients, so they may not find enough sections in their patient EHR. So same as other data set, they might have extra column for comments. So whenever they cannot insert the data in the options that is already provided, they just write a general comment. So you can train some algorithm to read those text documents. For your case, you probably have a spam folder in your email. What they do, basically, have some algorithms that read your emails, and if they predict that there is something wrong with that email, could be a virus or like some ads or something irrelevant, so they just send it to spam. And sometimes even they filter very important messages. They are not necessarily always good. There might be some error associated to each prediction. One of them is a spam prediction. Or automatic response generation. I'm not sure if you had that experience using Facebook. Recently, many ads are through Facebook Messenger. So there is a robot that texts you and shows you about some text about the topic or an item to sell, and you just start to chat with that robot, and based on your text document, robot gives you some suggestions. So it just comes from text analytics. These are the applications: information extraction, topic tracking, summarization, categorization, clustering, concept linking, and question answer. So these are the general terms that you might use in text mining. Unstructured or semi-structured data, we just talked about that. Corpus just means document. Terms, concept, stemming, I think they are very intuitive. Stop words. So when you read your document and you want to exclude some irrelevant or non-meaningful characters, some stop. So to give you an example of stop words. Exclamation mark. Doesn't need anything, so you can exclude your commas. You can find some association between words by synonym, and also tokenization means basically you find the most relevant word part of the documents and you assign a token. Let's talk about them further when we have actual data. So these are the terms that you would get familiar with that. Term dictionary, word dictionary, so these are the overall step in the text mining. The first step, we establish our corpus. Basically, we just collect and organize our data from the different sources. It could be a web crawling. Then create term document metrics, and at the end, we extract the information. But one of the thing that you need to keep in mind, the importance of word in each document. This is one of the basics of text analytics. So whenever you see a word in a corpus, you want to see if that word is very important or not, or should you pay attention to that or not. Let's say we are checking the student's email. Basically, we don't record. We don't want to identify them, or we don't be nosy to the emails. But let's say there's a email software which is not human and just reading all of your emails. I give you two examples. One example is a word, Netflix word, or the word of exam. So if your software see word of exam in the student's email, it's a very common word which you expect in the university. It doesn't bring any attention from algorithm. But what if there is a word of suicide? So it shouldn't be very common unless you're in a very bad situation. So it shouldn't, in the email corpus, word of suicide doesn't happen that much, hopefully. So when you see in the one document, it brings attention from software. Because first of all, it doesn't repeat it too much. So one of the ways that algorithms focus on the importance of word, but the repetition in the corpus. Maybe, and doesn't know anything about the word. For example, if they check the psychology department email, maybe suicide is a very common word, so it doesn't drag attention. So let's look at an example. So first of TDIF, which I just gave you two examples. It stands for term frequency inverse document frequency. TF, or number of times term T appear in a document divided by total numbers of terms in the document. IDF, logarithm of total number of documents divided by number of documents with term T. As an example, Consider a document containing 100 words where the word cat appears 3 times. So 3 times word cat happened in the document. Now assume we have 10 million documents and the word cat appears in the 1,000 of them. So logarithm of 10 million divided 1,000 is 4. So what if it just happened one time? Whenever there is not that much of document about cat, it just means it's not a common word. Maybe you need to pay more attention. So if there's here we have veterinary school, probably word of cat happens a lot of time. So let's say veterinary school means like schools that people pay attention to animal medicine. So in that school, maybe the word of animal happened in all documents. So let's say we have 10 million documents in the vet school, and all of them there's a word of animal. What would be the IDF? 10 million divided by 10 million. What is the logarithm of 10 million divided by 10 million? It will be the logarithm of 1, and it's equal to 0. So if there is a word that happens in all the documents, probably it's a very common word, doesn't bring that much of attention. So importance of that animal word in the vet school could be near 0. So let's say I have a software, doesn't know anything about COVID, and it just happens in the US. So it just search all the websites. Let's say check 1 billion web pages. Let's just calculate the idea for that. So let's say this is the first day of COVID. And so not you, that you're working with Google. You never heard about COVID, and your software never heard about it. So first 8 a.m. in the morning, you get 10 billion web pages from Google Engine. In 100 of them, you have word of COVID-19. And in one of those documents, it happened from 1,000 words, it happened 10 times. First of all, the IDF would be logarithm of 10 billion divided by 100. So it's equal to 5. And from that 1,000 words, 10 of them, there is a 10 COVID-19 in that certain documents. So TF, hair frequency in that document would be 10 divided by 1,000. So it would be 1 divided by 100. So it would be 0.05. So it will be PDF IDF of Word COVID-19 in one page of the Google search. Let's say that's about, this is like a CNN page. You have 100 words, there's a 10 COVID in it. So this is just a basic from text mining. In next class I explain more. So I just want to you guys know. So when we have a certain documents, each word might have different importance. Let's say COVID here has a like TF-IDF importance of 0.05. So versus if you have, what about the word of there? In the first day, you have 10 billion pages. Pretty sure it happened in all of them. So here, IDF would be 0. So it's one of the reasons that we just exclude those words. So when you want to look at the document, you want and judge about a certain document, there is some ways you can just exclude some words that isn't very important because it just happens in all documents. But there's some certain words that have more importance in the document. So we just draw attention to them. And this is a basic. So let's see how much time we have. Okay. So generally speaking, there is some famous applications of text mining. One of them is just finding the topic. For example, CDC read all of the tweets, and let's say from the words that people use in their tweets, maybe they are coughing, they have headache, nausea, they can understand where could be the outbreak of influenza in the country. So because word of headache, cough, nausea could be related to influenza, and when they read the text documents, they can understand what is going on in different parts of the country. So we call it topic modeling, and the topic here could be influenza. So you try to find the words that are associated with certain topics, and then with a good probability, you can assume what could be the reason that somebody make a tweet. Another one, you can look at the sentiment of tweets. Is it a positive sentiment or negative sentiment? For example, you want to see people's idea about president candidate in a certain part of the country. So let's say in Massachusetts, they read all of the people's tweets. Let's say in one tweet they said, good guy, nice, funny. So they assign a positive. Or in one tweet say, I bankrupt, bad president, whatever. So negative. Again, algorithm is not that much smart. You should give them some idea about what could be sentiment of certain words, and just sum up all of the sentiment, and we said this document is positive or negative. And one good application is just US elections. In some elections, some data scientists exactly predict what happens in the election. So using some text document or looking at the data, they could predict the future. So very cool application. So in the next class, we go further. We check the further structure of the text mining. Again, I don't expect you guys and don't evaluate your knowledge on the algorithm. We look at some good applications, and also we do have some hands-on experience using KNIME. So for the next class, please be sure that you have KNIME on your system. So when we do hands-on experiences, hopefully it makes sense. Any questions for today? So